Great. Welcome, everyone. Thank you for joining us today. This event was again organized by the quality engineer team of Albelli, and today's topic is Introduction to Security Testing. It is going to be presented by Rohit Patki, a security engineer from Albelli, and the presentation is going to last approximately 1 hour. And if in the meantime you have any questions, please feel free to drop them at the Q&A section, and Rohit is going to answer to all of them by the end of this event. So that's it from me. Thank you all again for joining, and let's go to the interesting part. Welcome, Rohit, and thank you for your time, and thank you for doing this.
Thank you, Eleni. Thank you so much for giving an introduction about me, and welcome all of you. Good afternoon. Let's see that this seminar goes as interesting as possible. I would like to be as interactive, and any one of you want to pop up with some questions, you can just raise your hand. We'll unmute you, and then you can ask questions anytime you want. So we'll try to make it as interactive as possible. Something about me, I would really like to give a brief around my background. So I'm a security engineer at Albelli. I have more than seven years of experience in security. I've specialized within the cybersecurity domain. I love to do cybersecurity in cloud security aspects, in application security, red team and purple team assessments, as well as formalizing a risk management and risk assessment process. And apart from that, from my work background, I also like to do something in ethical hacking itself in my meantime, like bug bounty hunting. I've also written couple of white papers for AWS, how to have a secure architecture in AWS cloud, as well as CVE hunting. Why CVE hunting? CVE hunting is very much different from bug bounty because it's more around a specialized software or an operating system. You have to find a really in-depth bugs around it. So this is a bit of a background about me. Let's dive in. Okay, so for today's session, we'll be discussing through all of these topics, which will help you understand security testing, the process, scope, and various methods to conduct it. So these are the topics that we'll touch today, and we'll definitely have at the end some demo of attacks that can also happen, and then I'll show you some use cases, interesting use cases around it. So yeah, let's start with the very first topic, the quality testing versus the security testing. Okay, I would like to first address that currently that there are problems relying in the pen testing as a core security activity, which it means is that the single control gate at the end of the development cycle, it's always has been a problem. The biggest problem is that it's far too late, and the interesting security vulnerabilities that we find are more around the business processes in the software itself. Now, if we want to get security testing out of this model, we don't have to start from scratch because we already handle a lot of other software properties in an agile and a CD models with a great success. Now, of those properties can be simply added to an application. We have to build them from the start, and security is absolutely no different. So many of the companies, they want to rely upon the external pen testers, or they really want to test it at the very end. So let's not do that. Let's start shifting left. That means a shift left approach is making security testing more closer towards the development of the code whenever the inception of the idea happens, whenever the architectures have been built, application flows have been built, incorporate securities in those levels from the start itself, so that it'll help to fix the issues from a very core level. I'll go to the next slide. Okay, so this is something really interesting. One is everyone is responsible for quality, move quality testing closer to the core, continuous automated testing. These are the simple basic aspects of quality testing. Why not security? Everybody is responsible for security. Move that security testing closer to the code, and obviously continuously automate security testing. So as you see, there are some things that are evolving. We are doing more and more automations. We are doing automated testing closer to the codes. The unit test and the integration test are key part to making continuous delivery possible. And I claim that we should take the same approach for security as well. Automation is definitely a must, and it must be done as much as possible, but it should always not replace manual testing. Manual testing should always be there, and it should complement the automated testing, which is going to happen. And yeah, definitely, let's give a shout out to our Albelli QE team, cloud team, my CD teams, and they're doing a really great job. They're helping us to secure the code, and then they're having good around flows around how to basically secure the CI/CD pipelines. So kudos to them, and it's going to be a good journey in Albelli as well. We're going to implement a lot of security aspects here as well. Another interesting example, there are really a lot of similarities when you talk about quality and security testing. The differences to the security testing are of degree and not of kind. We both are functional and non-functional testers, and we try to find those flaws in the software. We both are looking for defects, and we both are finding defects and testing the boundaries of the system. Where the quality test is more focused on the functional defects, security testing is focused on the defects that can be abused by any defined attacker, or it's for its own personal information gain or its own leverage. So so it's like you're looking for software failures in a very special way when you talk about security testing. Although there are some differences between the two, the differences is of degree and not of kind. So instead of treating security as a special kind of activity, you can also say that it is a special form of quality testing. The next part. Now, when we start with the process of security testing, how do we envisage it? How do we see that incorporate the security testing as a process in our organization or in our day-to-day activities? So these are the three probably main aspects what we have to look out for is why, what, and how. Where should the security test come from? The process differs from the functional requirements and the test. The central part of the process is the threat model. Why I'm saying the threat model is really important part in security testing is that everybody needs to understand what exactly is our application or our architecture or our organization is exposed to the threats. You can say who is likely to attack me, what are they likely to attack, and whether do you really care about those attacks. When we get to the threat model by analyzing, we actually analyze the business context, define the different type of data you're dealing, what's your risk appetite, how much risk are you able to take in, how much you can ignore, or ones that you want to fix it. Uh, let's talk about the technical architecture of application, whether it's a mobile, whether it's on web page, whether it's deployed internally, is it deployed on the cloud, is it customer facing. This all incorporates in the threat model, as well as some of the features like, is it an e-commerce application? Is there a fund transfer functionality? So each and every small functions within the application helps us to create this threat model. And at the end, it's like you perform a simple risk analysis on these threats which are currently there. And then you just try to sort out things that, okay, these are the threats that really matters to me. It can cause problems to my organization as well as to my customers and as well as to the platform. Or there are some risks which you say, okay, fine, I can take those risks. It might not cover a lot of damage, or it's something that is acceptable at all. So this is a complete process which is important when you talk about threat modeling. And as I really feel that the threat modeling process, it should be visible to all. That is to say, the whole team, the security team, the developers, even all the testers, they need to understand what and why we are building these specific features. How are we testing the work? How are we testing the platforms? How are we testing the code? It should be visible to all the team, and hence this will help to reduce the misunderstandings of the requirements, and in fact, which leads to ignoring of the security requirements. Here's a quick example, actually. There's a really interesting example I really want to show you guys, and anybody can raise your hand and tell me what's wrong with this. So this is a password forgotten functionality. Now, when I click on this, I say retrieve a password. I just put my email address. Now this comes up. Now, can anybody tell? You can raise a hand. We'll try to unmute you. Can you tell what exactly is wrong here? Yeah, we do.
Yeah, you're confirming that that address is not in the database. They can try again.
Yes, absolutely. You're absolutely right. I guess the thing is that this is actually from a functionality base, or you could say from a tester of a quality perspective, it's good, it's fine. There's not something the forgot functionality is working properly. It's supposed to go to the email, the reset password, and people are able to change password. But the problem here is that from a security angle, I'm able to enumerate which all email addresses are actually available within the platform. And then it comes that, okay, the request is successfully made, the password reset has been sent to you. Now I can start enumerating what are the email addresses which are currently present on that platform. This is the main problem. I specifically, I would like to talk about different examples. Like there were a lot of breaches happen before. I can talk about enormous amount of data getting breached, but those are real-time attacks. But there are also some platforms just like this, the Ashley Madison. Probably you might, everybody might know that what exactly this platform. It's an online dating platform for married people. And if you see the breach which happened a few years back, it's not something that anybody completely compromised Ashley Madison. What happened is that they had this password functionality which was implemented improper way. Now what the attacker did is that he enumerated all the email addresses and tried to see that whether the reset is going to them. And once the ones which are getting accepted, he published a list of, okay, these are the people whose email addresses are this, they're using Ashley Madison. Now, as you see that this got exposed, and then people got to know that, okay, my partners and my spouses are actually using these platforms, and they actually might be dating somebody else. So this was a huge, huge reputational damage to them. Now, if you see in this context, there's no problem. This is nothing as a breach. Nobody was actually hacked. Nobody hacked Ashley Madison, but just did the functionality of the forgot password thing. They were able to, the attacker was able to enumerate. So hence, that's the reason why I say that you need threat modeling, because we need to understand what are the threats for each and every functionalities, and then how you can model around it and how you can fix those issues. Now, a very good fixing for that issue is that definitely, like you just say that, okay, thank you for using this functionality. Now, if the email address exists in our database, you'll receive the email. That's it. You've closed one issue, one of the big issues, and probably one of the biggest compromises that can happen on your platform. So these are the some of the basic examples that I really wanted to share with you. Now let's move on to the next topic. Is what are the different type of security testing? As you see that there are different types of security testing. The thing is that each and every part of the security testing has a significant importance. Let's start with the security scanning. Why security scanning? So it's an automated process. Much of it is automated. Only the part is that you have to do the initial reconnaissance. In security testing, you probably start with the first phase, which is called as Recon. You try to enumerate as much information as possible about the target. You try to enumerate what are the DNS entries which are there for that company or probably for that platform. You try to find out different IP addresses. You try to gain as much information as possible. How many email addresses are openly available on the internet for that company? So this all becomes part of this security scanning process, where you try to enumerate the services and different ports, and you talk about all infras, hosting, everything in this. Then comes the risk assessment testing type, wherein you try to assess the risk of an application or an organization. You try to find out, okay, what are your architectures? How is your infrastructure deployed? How is your architecture of application deployed? How is the flow in your application? This is the probably the very first step that you do. Rather than doing it a direct way of attacking the application, you start first assessing at the very core level that how the setup has been done. You try to assess the risk around it. You see that, okay, some of the features which are enabled, or probably the DMZ is hosting the database. Just for an example, the DMZ zone is the zone which you want to expose the internet services to the server. Probably there might be a servers that you want to expose to the internet, but that has to be separated in a DMZ zone. But if you keep a database in the DMZ, that's an issue, because anybody can attack those DMZ servers and compromise and then get your attack your database as well. So hence, to stop those and mitigate those risks, you need to perform the risk assessment testing method. Then comes the vulnerability scanning. Now, once you know what are your IP ranges, once you know what are the services, once you know what are the domains, what you can do is that you can start doing some vulnerability scans on it. There are different various tools which are available. Some of the name is that you have your Qualys, you have your Nessus. OpenVAS is something, it's an open source platform where you can just try to put those list of IP addresses, and you try to scan them and then understand what are the ports open, and if the ports are open, what services on that ports are running, and if the version of those services are vulnerable, are those exploitable, or are those leaking any sensitive information. So that's a part where you start doing the vulnerability scans to understand what are the services which are open and what are the vulnerabilities which are currently lying in the environment. Then comes the next part, is the pen testing. Is the penetration testing is once you know, okay, I have the set of high critical issues, probably 10. Now what I want to do is that I want to try to see that whether I can test those out, I can exploit those vulnerabilities, and then try to gain access of the systems. This is the pen testing, where it also compromise of application testing as well. Why I'm saying application testing? Because see to it that application pen testing is also part of the pen testing. It's more about attacking the application end. You try to find out there are some vulnerable libraries which are present within the application, and then some probably some SQL fields which are injectable with SQL injections. You do the pen testing on the application, as well as you also do the pen testing on the infra level, because that's where your servers are exposed, your ports are exposed, and your services are exposed, and you try to penetrate through those infrastructure level as well. So that's the process. That's one of the methods and type of testing for security, the pen testing. Security auditing. Okay, so security audits, it's more around the processes, the policies, and the controls. Whenever an organization is formed, it always have to have its own information security policy. It might have to abide to some regulatories, and some of the examples I can give is that if you want to follow NIST, you can follow NIST frameworks. You can, if you are a customer facing company, then the customers might ask you, okay, are you ISO certified 27001? Then these are the policies and procedures that you have to follow, and you have to comply with them. What happens in security auditing testing is that you try to assess these processes, then you find out what are the controls which are applicable to these processes, and whether are those compliant. Just for example, I'll tell you that if at all you're spinning up an Windows 2016 servers, and if it's not hardened at all, there are certain baseline benchmarks which are present for each and every flavor of Windows, or even different systems, and those has to be complied. You need to have those benchmarks in place. You have to harden those servers, and then only you can make those productions make those servers into production. So this is where the security auditing comes in, where you look onto the more around the controls, the process, and the policies. And yeah, and then comes the part is the ethical hacking. Now, what is ethical hacking? It's a complete real world hacker simulation. So it's not going to be something that a tester who comes into the company as a consultant, who is given access to the internal portals, and then he can go around and start doing his assessment, and then like he'll have a view of it. No, ethical hacking is in a ethical way. You try to hack and simulate as a black hat hacker. You try to impersonate as a black hat, and then you try to attack from an external perspective. Now, what are the external perspective? It's not just about hitting the applications, but also people, process, and technology. I'll give you more examples. I do have a special slide for this. I'll give you more examples how we can do it. There's something term as called as a red team or a purple team assessment for the ethical hacking thing. We'll discuss it more later. And the very last part, it's a posture assessment. Now the posture, once you have done through all of these steps, all the testings have been done, you know that you are at a certain level, that okay, fine, I feel that all the processes are there, all controls are, we are abiding to all the controls, we are doing continuous assessments, and we have monitoring and everything in place. Now, but still I want to understand how's my posture, how's my cyber risk. I really want to know that where my company lies from a benchmark perspective. If you say that e-commerce has a benchmark of around like out of 190, where do I rely? Where do I lie? Where am I scoring? So this is where the posture assessments testing comes in, where you understand, okay, I'll be more clear, and I'll give you one more example. Is that I fixed one issues. For example, there was recent vulnerabilities of Spectre and Meltdown, which had a huge effect on a lot of internal servers. What I do is that I complete all the testing for it. I understand what's the scope for me to fix those issues. Now, once I fix it, I feel that, okay, fine, now I'm at a score of 100. But what happens is that after 2 weeks, there's a new vulnerability that has come up. Just for example, you have your FireEye, which was open up with a lot of tools. And if you have certain FireEye instruments or probably solutions deployed in your organization, you might be exposed to attack. Now, what happens that I don't know, there's no security expert guy who is giving a continuous feedback to my company and who understands the landscape and tells me that, okay, we are currently again susceptible to attacks. Now, this is where the posture assessments helps a lot. Now, there's a new attack already. Now, your score has already come down to 50 or 40 because you're again, all your servers and systems are vulnerable. So this is where the posture assessments help you. Now, I want to start again with the process of fixing all the issues, probably targeting the systems which are vulnerable, and then again go through a process of complete cycle of all these testings. That's why it's a continuous feedback format, wherein you have to have this all the time. So let me know. I'll pause for now. If anybody has any questions or anything you want to put any chat, let me know. Oh yeah, I can see the CV. Yeah, it's common vulnerabilities and exposure. Just to give you a brief, Michael, it's about every vulnerability which has been released in the market has a CV score or a CV ID. the CV ID uniquely identifies that issue. So even if rather than probably you might not even know what that vulnerability is about. Just for example, take Oracle. Oracle might have thousands of vulnerabilities into it, but then you will not be able to search each and every vulnerability by its small model names and everything. So that's why CV ID comes into the picture, where you try to just paste that CV ID and you'll get all information about the vulnerability, which platform, which version, which exact component is vulnerable to it. Yeah, so that's about the CVA. And anything else? Anybody wants to? Anybody has any questions? You can just raise your hand. We'll try to unmute you. Yeah, Akshay.
Am I audible?
Yeah, you're audible.
Yeah, as you explained, security is really vast topic, and here we are
Yes.
generally doing front end and developing, let's say, back end or middleware in GraphQL, and we are doing a lot of test automation in there. How to start this thing, and what are the basic steps that we need to follow? Like we can check vulnerability like NPM audit or something. What are the things we put in pipelines to make sure we don't have these kind of thing? So that's the basic thing I'm just struggling to figure out in the pipelines. Where can I fit that? Yeah, that's it.
Right. So I'll give you more information as we go on, because your questions will be answered later on, because I'm going to take those things into place as well, because this is really an introductory, but then I'm going to talk about more that later. Probably I'll able to address that later. Is that fine? Is that okay?
Yeah, perfect. No problem.
Yeah. Anybody else? Anybody wants to? Anybody has any question? Cool. Okay. We'll go to the next slide. Okay. So this is where the basic testing methodology is for the security, wherein the phase one is the discovery, where you try to discover, you try to see the digital footprint, you try to find out embed services, ports, and even the application. You want to spider around the applications, understand which are the different subdomains present, and what are the different APIs which are getting called. So all this happens in the discovery phase. The phase two is the service enumeration, where you try to enumerate as many services as possible. You try to do some ping scan. You try to do nmap scans. These are some of the tools I'll show you later on how it's supposed to be done. You try to see that if how many things are getting exposed over the internet, and then you try to enumerate. You try to collect the versions as well. What's exactly on that port, which is a service which is running, and then how much of more information that you can get. There's banner grabbing as well. You need to understand whether the application is hosted on IS platform, is it on Apache, is it on Tomcat, different type of information that you want to gain. The next is the application testing, where you then, once you have all the information with you, you try to conduct the application testing, wherein you try to enumerate exactly if you find the issues within the application and try to do some attacks on it, and then you try to just like find out, okay, these are the vulnerable services, and these are the vulnerable sections within the applications that I might be able to leverage and try to do other exploits as well. And then comes the penetration and the compromise part, wherein once I know, for example, an application is vulnerable to Sql injection, what I can do is that I don't want to stop then and there itself. I just want to go ahead. I would like to upload a shell, or probably compromise the system on which the database is hosted, and then try to enumerate within that and do a lateral movement in the network of the organization and try to find out, okay, whether I can compromise any more systems or not. So again, it's like a circle. It's you keep on once you penetrate inside an organization, you keep on again doing discovery, try to enumerate as many systems as possible till the time you hit the crown jewels and you exfiltrate the data outside. So these are the basic testing methodologies that we follow during the security testing aspect. Okay, so now I want to focus more upon the application security risks. What are these risks? Actually, there's a team called as OASP, which is an open web application security project, which helps us to actually mitigate the risks which are currently lying in the applications. These are the top 10 risks that might occur in any of the applications which are getting developed or probably in production. So this is a top 10 list. You can go and have a look around it, what exactly they are. I'll start with giving you some of the examples. Like the very first is the injection attacks. So injection attacks happens from an untrusted source, and the data is sent to the code interpreter through a form of an input or some other submission to a web application. Just for an example, the Sql injection, where I try to, if I'm supposed to view only my data, but I'm able to, with a special query, I'm able to enumerate the whole database and try to get information about all employees or all customers within the platform. This is some of the examples of injection. Then you have your broken authentication. Vulnerabilities in authentication systems, they actually, I would say that authentication is one of the major part of an application. Sometimes you see that I'm able to brute force an application. What I'll do is I'll continuously hit that application with numerous username and passwords and try to see that I'm able to break it. There's no 2FA enabled, and then if I'm able to leverage that and try to attack and try to guess the passwords. So these are some of the examples of broken authentication. And not just that, even sometimes there's a special case called as credential stuffing. So I want to give this example is that why credential stuffing is a bit different is that you have your Gmail password, which has got exposed over the internet. Now the same username and password is been used by the customer in another platform, probably your own platform or your own application. I might use that. I might start doing credential stuffing attacks where I know the credentials of yours and try to just enumerate on the different applications and see that if I'm able to log in or not. So these are the basics. Like these are the ones which are attacks are possible in the broken authentication part. Now, sensitive data exposure. This is one of the attack vector wherein you're exposing your sensitive data. For example, the error messages. Sometimes I feel that many of the companies don't look onto the error messaging part, wherein if I'm able to just give a wrong query to the application, I might get some sensitive information as a part of the error request. I understand what's the backend technology, what are the host who's there at the behind, what is the internal IP addresses, and number of examples that can be given as part of sensitive data exposure. And then the fourth is the XML entities. Now this is really making a bit less because people are not using XML and XML entities, and they're not passing XML as an input. So, but still, a lot of applications use that. So what we can do is that I can actually attack through an XML input. And if there is a vulnerability in the parser, I can retrieve the data from the storage where the data is getting stored, the complete output, and just it's same like Sql injection, wherein just I'm using an XML format or an XML type of attack to retrieve the information back. Then you have the broken access control as well. Yeah, there's a difference between authentication and access control. Access control is more is about the system functionality and authorization. If at all, for example, you are an admin user and I'm as a normal user. Now what I do is that I just change the ID of my login and I start enumerating internal application APIs and see that I'm able to call all the admin functionalities at my side. So this is one of the example for broken access control, wherein you need to have an authorization tokens, session IDs tagged to your each and every user so that it's only able to access the things he's supposed to. Security misconfigurations, again, it's like the services which are exposed. For example, if an FTP server is exposed over the internet, or an application which is using an internal functionality, but then that port has been exposed over the internet, I can leverage that and try to see that whether I can penetrate and if that port is vulnerable. Even some of the another examples is that you probably mentioned the version names, and in the response HTTP response headers, you try to mention those version names, more details around what exactly is at the backend, what's running. So these are some of the common security misconfiguration. Cross-site scripting is again, it's one of the famous examples wherein the users are allowed to add a custom code into the website, and that will be seen by other people. So it's like injecting a malicious JavaScript into the web applications browser. I'll give you an example. It's a very simple example. An attacker could send an email to the victim that appears to be from a trusted bank, and with the link of that bank's website, what it does is that now the user goes and clicks that link, and the malicious JavaScript is now being executed. And if the bank side is not protected well, it might even execute at front transfer, because the request has been formulated in such a way that it understands the flow of the bank application, and then it automatically triggers the API. So this is one of the examples for excesses. Insecure deserialization. Okay, this is also one of the key topics when you talk about security testing, is how the way you serialize your data or you deserialize your data. I can give you a very simple example. If you're moving from one place to another, or you want to pack your furniture into a small box, it's called a serialization, and then you move to the next place, and then you unpack it, and then that's called as deserialization. It's just about showing, having a data in a certain format when the applications wants, the customers want to view it, and then the backends when it's want to interpret in a different way. Now, what I do is that if at all I am sending a serialized data from my own source, if there is no source checks within the application, I send my serialized data, and then it deserializes at the backend. What happens is that an exploit or malicious code gets executed at the backend, and I might even get a shell back. Or what I mean by shell back is a control of that server back to me. Also, there are a lot larger instances when insecure deserialization is used for DDoS attacks. I try to flood with a lot of deserialization requests, and then there's a complete DDoS for the organization or for the platform. And using the components with the known vulnerabilities. Again, it's about when you know that, okay, SSL Poodle, for example, 443, there are some old ciphers which have been used. These are some of the old known vulnerabilities, and then you leverage that and you try to attack the platform. The very last part is the insufficient logging and monitoring. This is where, again, when you don't know exactly what's happening within your application, if you are not monitoring your application from a security aspect, I could always see that companies do have logging and monitoring for the performance base, but then there are no monitoring on the security side. So, but this is really important, wherein you need to understand, okay, some attacks are happening on me, or somebody's trying to do something malicious, somebody's trying to scan my environment. You need to have those logging and monitoring triggers at place, so that you might avoid something which is going to happen in the near future. Again, as I told, it's for the SQL injection. The very simple example is about, as you can see in this, that an attacker, instead of enters a SQL command for the student ID, what normally the query would search for the database is for the matching ID, but it now looks for an ID and tests if 1 is equal to 1. Now there's a Boolean logic that runs behind. It might be not a same case for all the databases, but then if you see for most of it, it does that. And then, as you might expect, the statement is always true. And for every student column, it is given, the result is given yes, and then it will return the data of all the students and not just for that one single student. So this is just one of the examples of SQL injection. What extent can you go with SQL injection? It's not just about enumerating databases or data within the databases, but also you can compromise the whole database system as well as the internal network. Because there are modules within SQL injection. You can even upload a shell, and then you can get the a callback of the shell at your own attacker side, and then you can compromise the whole system, and then you can start doing lateral movements, and then you can jump from one server to other. So that's why SQL injection is treated as a most highest priority, and you want to fix it. Again, so broken authentication is, again, where I talked about, is the brute force, where you try to brute force again and again, try to see that whether the credentials do work or not. There's a second part here, is rainbow tables. It's again interesting. What are rainbow tables? It's basically a dictionary of hashes. If at all your application has functionality to hash out your passwords, now what it does is that it keeps on probably admin is a username, admin is a password, but then I can calculate the SHA-256 or MD5 sum or an hash for that admin password. Now, like these well-known passwords, I do have a dictionary for it, and I calculate the hashes for it. Now, what I do is that I keep on hitting those hashes and try to bake those authentication. That's one of the example for rainbow tables. Session hijacking. it's again where I'm able to hijack the session of the user. If I know the session ID, as I carry out some attacks and try to find out the session ID of the genuine user, I can just impersonate as him and then try to gain access to the application and his all resources. Broken access control. It's again one of the examples that we discussed is as an attacker, I'm able to send you a link via mail, or I'll be able to make you click on certain URLs. Now the website, the genuine user clicks it. The website is now as access, and then he's already logged in into the website. It just opens into his same browser. The same link is open, and now able to carry out the functions which the application is intended to do as a genuine user. Another example is the sensitive data exposure, wherein it's again most of the attacks. If you see an example, most of the attacks happens via the phishing. Almost 46. There's a chance rate of 46% of all around world the cybersecurity attacks are happening via the spear phishing emails. The phishing email bypasses all your antivirus and email gateways, and then it's reach out to the compromised user. What it does is that he clicks in the organization, and there's a possibility that all the sensitive data from the organization is now been sent out to the attacker. That's one of the simple examples for sensitive data exposure. The cross-site scripting. It's again it's the same, wherein I attach as an attacker, attach a code into a legitimate site that will execute and load victims' website on the website. So it's called as a store XSS, when I'm storing that query, JavaScript query into the server. Whenever, so any genuine users who will try to visit that site or visit that exact page or the functionality, he'll be able to call that script, and then I might even able to gain session of all the users currently which are logged in within the organization, as well as the extent of XSS is again it's about like I can go on doing compromising all the systems within the organization. There are different ways and different payloads that I can carry out by using XSS to compromise the whole system as well. Okay, I'll pause for here. I have a question. Hello, is it possible to talk about downloaded MSI file security? The software agent is to feed an RMM with live data about hardware and software all devices. An extraction of MSI leads to 15.dll file, and that have access to all devices, including remote screen. Yes, absolutely. So this is it's more around your real-time applications, or you can say that the fileless malware. Yes, you can talk. I'll just unmute you. Yeah.
Hi, thank you so much for taking my question. I would love to hear your opinion on this, because this is very relevant to what you're talking in terms of high risks. And how do we assure, because the company doesn't have a third party that audited their MSI, they have internal security team. The secret sauce isn't that MSI of theirs. And the thing is, if we want to uninstall their MSI, what are the guarantees that some of the DLL files don't stay in the registry? Thank you very much.
Right.
I'll mute myself. This is Hyatt speaking.
Right. So it's a very special case. And then I like this this question is because it's more around. Now, if I give you a brief example, what is an MSI file? So it's like a downloadable. It's a setup file within the Windows environment where you try to carry out a setup of a software or something. I can impersonate that and try to send it via phishing email. And I've seen a lot of examples, and we have done it before in many of my red team assessments, where we try to send those MSI files, and then we are able to execute that remotely and even gain privilege access. So now what happens is that I'm now logged in. I've already compromised the system. I've logged in as a normal user, but then if I want to escalate my privilege, I want to be an administrator, or I want to go to an anti-authority system level, just for Windows sake, or as it's an MSI file. Now I do introduce these MSI files, and this scripts loads, and then the DLL files are loaded into the registries, and the processes are invoked, and then I can talk about it in my different sessions about how this DLL injections happens and how the attacks occur at a very deeper level. But then, coming back to the question to you, this is where you need to have there are two parts to it. The very first is I would say that you need to have an EDR solution for it. EDR is one of the good platforms. It's endpoint detection and response. Now, what it does is that it understands this logic behind it. Each and every malwares or MSI files which comes in into your system, it understands the path, and and if you know about the MITRE attack framework, it has all the steps defined into it. Now it knows that okay, there's a new process which has been injected, DLL files are getting created, and that doesn't have some vague process IDs into it. It immediately flags it and then stops that process then and there itself. Now, if you say that, okay, I'm a company which I cannot afford an EDR, then you definitely need to have some alerts written down to it. I would rather say that there are tools called as Sysmon. Sysmon is one of the sysinternal tools which you can use it. You can actually keep on monitoring. There are certain changes which are happening. Any new processes are getting created. That's one of the ways that you can actually at least know to yourself that you have a real-time alerts on set on them. And there are even I can talk about different event IDs that can be mapped to each and every events which are getting created, if at all an MSI file lines in your system. And that's the very basic step that you can do, and you can at least have an alerting system on that. And yeah, and the very last part is you have a SIM. If you have a SIM solution, SIEM, that's the very best where you can keep on monitoring all those. So let me know, like, hey, did I answer your question? Do you think that's fine?
SIEM.
Yes, SIEM. It's a specialized team which takes all the logs from your organization. Like you talk from your system event IDs. If you have antiviruses, then you have all logs from them. It takes all your sys logs, all your Linux systems logging. It logs into its own platform. It has set of use cases which have been defined. So you talk about each and every steps that you have mentioned here, controlling of the cameras and screenshots and everything. For each and every steps, these have been defined. And if at all that event ID is triggered, immediately has been alerted to the team saying that, okay, the ticket is generated. Okay, now this is something malicious which is happening. And now can you act upon it? Can you see that which file has created this process, or this, is there any attack which is happening? And that's how the people do the forensics and the triaging afterwards.
Excellent. Thank you so much. Is it okay if I reach out via email or LinkedIn?
Absolutely. Anytime.
Thank you. It's been a delight. Thank you very much for answering.
Thank you. Okay. So I'll move on to the next is the last part of this for the OWASP top 10 is the redirection attacks. Again, it's the same, like always be careful of the redirections. See to it that your applications handles redirections in a proper way. Every user has a unique identity and has a unique session ID tagged to it. You can do the tokenization as well, so that any external link coming in and try to access your internal API calls, it should be blocked immediately, or probably the response should not be given to it, or an error should be reflected because it doesn't have that session ID or a token. So always look out for that. Now we move on from the application security testing part to an infrastructure testing part. This is wherein I talked about when you try to hit the applications, you try to see that you try to map yourself on the OWASP top 10, try to see that, okay, I have the checklist of OWASP top 10, I can try one by one attacks and see that whether the application is secure or not. But when you talk about external pen testing activity or an internal pen testing activity, it's completely on the infrastructure level. You try to attack the firewalls, you try to attack the routers, you try to send the phishing emails to the internal users. As I told you at the very beginning, the reconnaissance part for this is really important. You try to find out as many as information about the company or your own application from the internet. What all data can you get? Just name the few tools. You can enumerate all the email addresses lying on your internet of your company within few minutes. There are few tools I can share with that you later as well. You just have to run those tools, and then you'll get the information. Okay, these are a list of users who have email addresses exposed over the internet. And that does really happen because email address is not as such treated as in PI data. Usually people tend to give those email addresses outside for a business perspective. But now what happens is it gives me a leverage. I can now send, I have a list of employees and I have all their email addresses, and now I can target them by sending the phishing emails. The phishing emails is sent that might be, I'll give you one example. I can send a Word document stating that this is your salary change, or probably this is a salary change of your some other employee. For example, employee A, I'll send an email stating that, okay, employee B salary, your salary has been changed. please have a look into it. Now, this is really enticing for people. Like I've seen that times where this phishing emails are even fooled. Like the hackers also get fooled by these phishing emails because it's so enticing. I said that okay, I'm able to view somebody else's salary. Why shouldn't I open it? You just go and click it and open it. And what happens is that in the Word document has a macros built in. It runs a macros in the background. It leverages if at all there's no antivirus, and if the antivirus signatures are not updated. Now I'm doing an attack at the background, and I immediately get the response back to my CNC server. Now, what's in CNC server? It's a command and control server, which an attacker sets up to call back all this attacks which are happening, all the malwares. It has to always communicate outside, right? It has to exfiltrate data. So this CNC server acts like a single point of contact for the attacker. Now the call has been sent back, and I'm compromised. Your system has been compromised. So these are some of the examples for like an external perspective. And I'll give you an example in the demo as well, that how you can do the steps for each and every testing phase. Like you do enumeration, you discover, then you try to find out services, what vulnerability is there, and then you try to do attacks. So from an external perspective, definitely you try to scan the perimeter, and then after that, how do you can step inside the organization. What are the next steps? You do some traversal attacks. You do some path traversals. Like I can shift from one web server to other web server to databases to different sections in different trusted zones. That's from an external perspective. Internal pen testing activity is also one of the important thing. The reason being is that I can emulate myself as an external attacker, but what about insider threat? Inside the world statistics says that almost around 80 to 80% of attacks happens from an insider employee. The reason being is that if at all internal services are exposed to each and every one, I don't have a segmentation in my firewall. All I can reach from my desktops within the office to my server segments. That's an issue because an attacker from an inside perspective, I can just go on and try to do attacks, and then even impersonate myself as a external attacker, and then send all the data outside. So this is the reason why you try to do all the testing from the inside perspective as well. You try to find out, okay, these are the vulnerabilities which are present inside, because you will see that there are many applications, many services which are exposed internally, which are very hardened at perimeter level. But then if you see from inside, it's all exposed, and then insider can easily attack them. So these are the two types of infrastructure pen testing. Okay, I'll come to this last part of the testing, which is called as a red team and purple team assessments. Now, what's the difference between an infrastructure pen testing and a red team and purple team assessment? I would say red team is completely going black hat. Nobody knows anything it's going to happen. It's a sudden attack that happens to the company. Purple team is more about it's a teamwork, as in the internal blue team knows that somebody is going to attack and the activity is going to happen, and red team will try to do different ways of attacking the company, and blue team will try to stop the attackers to penetrate into the organization. So hence the combination of that is called as a purple team. When the insider knows, okay, something bad is going to happen, the team is going to do an assessment on us, but then we want to be ready for it. So these are two types of specialized attack. Now, what happens in this? I would say that the pen testing or the vulnerability scanning is about finding out as many flaws as much as possible within the whole organization. Like I would want to know what are the different services, what are the different vulnerabilities which are present. I want to find more and more. Red team is not like that. Red team is completely concentrated attack. Even if I find one vulnerability, if I'm able to find one vulnerability, and if I'm going to use that and compromise the very first system, and then later on, I'll try to do some traversal attacks. So this is where the concentration comes. I don't want to find a lot of vulnerabilities, but then I only want to find one vulnerability. And even if I'm able to compromise that, I'll start my doing the depths of the attack. So it's more about the depths. If you see the step here, is that the first is definitely the initial reconnaissance. I want to find out, okay, what are the services exposed, what are the apps which are exposed, what are the applications the company is providing to the customers. Then I do the first attack. I try to establish the first initial compromise. That might be the first system within the DMZ or the one which has been exposed over the internet. And then what I do is that I'll try to do some privilege escalation. There are chances that if I do a first initial attack, I might not even get a hash. What is hash? Hash is a root of that system or an administrative privileges. I might only get a user per privileges. Now what I want to do is I want to escalate the privilege. I see that, okay, there are some services which are running. Just as the example that we had here is the MSI file. If I have the MSI file, if I have some cron jobs running in the Linux system, I can try to inject my code And then what I do is that I escalate my privilege. Now from a user, I want to become hash, I want to become administrator. Once that is done, then I want to do another next step is try to do an internal recon. I'm already inside the company and try to do different reconnaissance, try to find out, okay, which is the server segment, which is the database segment, where is the data center lying, what are the different connectivities, is there anything connected to the cloud, whether I can go to the cloud from the DC premises. So these are different ways that you try to enumerate, and there are fantastic tools available. Like it might sound it's a bit tedious. Yes, it requires a lot of time, but then there are fantastic tools that can do a lot of good help to you when you do these assessments, and gives you good information. You can enumerate all the AD systems, which are the ones with weak passwords. You can enumerate all the hashes. You can do some of the attacks like parse the hash attacks. You can even have a responder. There's one of the responder tool that you can have a look into it, wherein you just set up a fake proxy and fool the people around, saying that okay, you can authenticate to me, so that you can grab all the hashes, and then you try to do different attacks. And then you can even reach out at this very sensitive level of databases and some transactions which are happening at the server end, and try to manipulate those. Once that is done, then you or try to compromise at a different level, at different systems as well, and different sections of the organization. You try to maintain persistence as well. You try to see to it that it's not a one-time activity. It might take some days. So I might even switch off myself for some time. But then if I again switch off my CNC server, or probably my controller, it has to again give me a call back. What that means is that I have a backdoor in the organization that whenever I want to switch it on, it will again call me back, and I'll again gain access to the systems. So these are the things that are involved in the red team assessments. Once you exfiltrate the sensitive data outside, once I hit the sensitive data, I understand, okay, this is a genuine data for this company. I'm now exfiltrating it outside. The very last step is the covering of tracks. Now I slowly remove all the malwares, all my payloads within the organization, and I cover all the tags. What I do is that I tamper the logs. I probably remove all the files which have been generated as part of my attacks, and then I see to it that all the alerts of which are probably, if they are configured, I see to it that I remove them, and then I safely close my doors and then come out of the organization. This is usually what happens in the real world scenario as well. People see to it that have you ever heard that almost all attackers have been caught, or probably people were able to know how the attack happened, and then how the ones which actually conducted the attacks. But that doesn't happen. The reason being is this only: they're able to simulate this complete cycle in such a proficient way, is that they're even able to cover the tracks. And I'll tell you, even in this nowadays as well, you see the big breaches which are happening. Even if you have the world best in class EDR solutions, attack like all your different defenses, all your different solutions, perimeter level security, still those attack happens, is because it's about the human tendency. Like you are always susceptible to some error which is going to happen, or some service which is going to get exposed on the internet, and then that might be a point where the attack starts. So this was about the red team and purple team assessments. This is one the last part of it I wanted to discuss. But before that, I just want to ask people, like, if there are any questions, anything that you want to ask till now. Is there anything you want to discuss around? Okay. If not, then let's move ahead. We'll move on to the next topic, which is the DevSecOps. Yeah, this is a really interesting topic. I really like to talk about this, is because it's something which is really new that's happening. And as I talk about the shift left approach, wherein we want to move the security testing closer to it. Mostly the topics that we covered today is more around the mix of automation. Automation is main about finding the vulnerabilities, and then automation is about exploiting. But then what about something which is getting closer to the code? This is where the DevSecOps kick in. And it's a really vast topic, and I'm just giving an introductory for this. Look out for further sessions from me. This is a really favorite topic of mine, wherein I would like to set up a proper systems and a proper pipeline, so that each and every one of us can understand how the security works in the pipeline. So as you see here, the main, if you start with the complete cycle of DevSecOps, probably DevOps, it's about plan. Like the first phase is where you start planning. Now, each and every, if you talk about quality engineering as well as development, each and every one has to play a role in each of these different steps within the DevOps field. Now, if you see, I've aligned it more towards the security aspects. Talk about first is the planning, where you start doing the threat modeling. You see to it what are the different security requirements, what are the security SLA providers, and then you do the risk analysis within the plan phase. When you have the code, you do some automated software composition analysis. Now, what is software composition analysis? The SCA. It is about finding some vulnerable libraries which are being used. If at all anybody is using some vulnerable old libraries, that can be found out by this. If there are any misconfigurations within the code, the same thing can be found out. Now, if you see here, this is where it helps a lot. When you start coding, if you have some of the IDE plugins, which itself gives you out saying, okay, I've started a statement about and start coding about the SQL parameters. The IDE plugins itself gives you a notification stating that, okay, this is something which is probably SQL injection is attacked on this code. Can you fix it? So this is where it helps a lot. Like you're from the start, from the beginning of the program. Sorry. Are you able to see, guys?
No, we can't see your presentation.
Okay. Yeah. Can you see now?
We can see your presenter's view now.
Is it visible now?
Yes.
Okay. Okay. So yeah. So when you probably code at that time, you should probably incorporate those IDE plugins, which gives you those alerts stating that, okay, this statements and this the code that you're coding is vulnerable. And many times this IDE plugins are so helpful that it would even gives you a recommendation then there itself. So it, for example, dev skim, if anybody have you guys have tried within the Visual Studio, or sync your snake, or probably I would say that if you code it and then if you click it then and there itself, it will show you the best way to code that, and it auto corrects that. It's automatically corrects those statements in a secure way. So these are things that you really would want to do part of your from the shift left approach, where you start at the very code level itself. Then you have your automated container image scanning. You try to scan your images, whether those containers images are vulnerable. Are there any security loopholes into it? And then also your code repositories. If you have you're using Artifactory or your artifacts, you can probably scan those as well. Now, when you come to the build phase, that's where you have your automated static testing, where you start scanning the static code. You try to integrate your security testing with your unit testing. Then you see to it whether you have runtime application which are running, then you can do their security testing on them. These are the scanners. This is again an automated format where you try to scan your code and try to find out as much as vulnerabilities as possible and highlight the developer team as well as the different teams so that they can fix it before it goes into production. Now, when the phase comes to a test, that's where, when you know that you have fixed everything, you have already fixed the libraries, you have fixed the code, everything, still, there might be some business logic bypass that can happen. And that definitely no automated scanner in this world can ever tell you. That's the reason why we need to have manual testing always, and it has to complement the automated testing. The reason being is that I can understand, as a human brain, I can understand what a payment module or a payment section is supposed to do. But then the automated scans won't give you out vulnerabilities. For example, if an application flow is supposed to probably I can change some values within the payment sections. I can buy something at a cheaper rate. I'm just giving you a simple examples that the automation of a scan will never be able to give you. So hence, you need to have those manual tests as well, which you try to penetrate, try to find out different scenarios where you can attack and try to exploit the application, and then try to find out as much flaws as possible. Once that is done, then you have your release phase. Now, this release phase is again, you do your CI/CD pipeline securing. Once you set up this pipeline, you set it up on AWS, you set it up as part of your GitHubs, or you set it up as your Azure in your cloud platforms. You always will have a benchmarks for it. You will always have some security baseline benchmarks that you need to comply to it, and you have those hardened pipelines in place so that nothing gets leaked out, or probably nobody compromises your pipeline. Once you're deployed, you need to also see that how you manage your secrets. Another very good topic is about the secrets being part of the code all the time. Those are getting committed into GitHubs, if repositories, those repositories are access to the public, or whether they're in a closed loop or not. Even if there's a closed loop, there's no reason for us to commit probably the keys into the repository. So those checks, if at all any code is consisting of those keys, it should be immediately be flagged there, and the secret should be managed in a special way wherein you just have an identifier for that secret, and it should be called only upon when you have. So there are good examples, like you have your GitHub secrets management, you have AWS secrets management, where you have an parameter or for a secret, and then only that parameter has been called in fact in place of actually putting up the keys in the code. Once that is done, probably you can see that there's an operate phase as well. You try to do the incident response, as in you try to purposely, or probably you want to make that application go down and see to it that how the application behaves. How are you able to recover? If at all there's an attack really happens, if anybody compromises complete within the cycle, anything is compromised, how you will probably recover from it. This is the way the incident response techniques comes in, and then these actions and these plans helps you out to understand, okay, this is my RPO or RTO just to recover, how much time I'll be able to recover if at all any crisis happen. And the very last and good part is the monitor part. Obviously, it's wherein that's where I like to do a lot of work. Talk about monitoring, about you have to monitor continuously what's happening in your complete pipeline. You talk about different defenses techniques that you have implemented, log those all sources, log those in your use Elastic Search. You can use Splunk. There are different platforms that you can use for log management. You can log those everything and start monitoring them. Start like building up queries upon them so that you can understand, okay, there's something wrong going into my flow, and I can, if at all, I can just see to it as soon as possible. I might even stop a bigger risk coming into the organization. So define all this, and this is the complete pipeline overview I just wanted to give you. The thing is that DevSecOps, again, as I told you, it's a really big thing. It's something that cannot be covered in a short span of time. I would definitely love to have a special session on this. I can demonstrate you how to secure a pipeline, how to put all those things in place, and launch a successful production application. Okay, so some of the interesting, I guess Akshay was asking that how we can do it, how you want to do it, because you see that there are a lot of stuff that you do within the pipeline, and how you can do it. So these are some of the very simple examples. I really want to give it to you. I've used many of these, and I feel those are really good to have, and you can use them. Many of these are open source as well. Not everything is supposed to be commercial. You can make use of open source community. I love the open source community a lot because you can contribute so many things of it. But then, these tools require fine tuning a lot, because again, it has to be catered to your organization, your requirements. So it takes a bit of a time to fine tune all these applications. As you can see, the IDE plugins, I talked about DevSkim, Sync, and JFrog. You can use these just to find out within the IDE plugins. You can just find out any issues so that the coder or the developer who's trying to code himself within his typing, when he's typing the code, he will immediately get alerted. Then you have your pre-commit hooks. You can talk about GitHub secrets. Talisman. Talisman is a really great tool. It gives you understanding about what are the vulnerable repositories currently present, libraries which are exploitable. At the very initial level itself, you get to know those, and you will able to fix it at a earlier level. And then definitely you have your secrets manager, where you try to use, if you're using GitHub, you're using HashiCorp Vault. You can use secrets manager. It's again, we talked about the parameters as well, rather than passing all the credentials into the code. Then you have your SAS. SAS is again a static analysis of the code, wherein you try to run through the scanner through your code and try to find out if at all your code is vulnerable to any of the issues. So these are some of the examples. Then you have your SCA. It's again that we talked about is a software composition analysis, wherein you have to find out how many vulnerable libraries that you're using, if there's any issues in the code repositories. These will help you out a lot. By the way, also the SCA, you can have a lot of bots set up within your organization, or if you're using cloud, especially, it can give you real-time alerts that whenever the phase has been kicked off and the scans happen, you can immediately get an alert around it, and you can have a dashboard and report which states that okay, this application is getting launched, and then but these are the vulnerabilities currently existing, and all of this can be fine-tuned, as in you can completely put it in the monitor mode. If you don't want the production to be hampered, just keep it in the monitoring mode, keep it as a parallel mode, try to scan those, let the application go in production, but then you immediately notify the developers as well that okay, these are the scans that happen, I have the results. Now can you just have a look into it, can you fix it, take some time span and fix those issues. And once you are confident enough, okay, there has been significant amount of time that we have been fixing issues, and now I see that all those scan results are getting lower and lower, I'm not getting any critical and high issue, then you move on to a active block mode. When you see to it that okay, now I'm confident enough to go into production, because now everybody has learned, even the developers has learned to code it in a secure way and launch it in a secure way. DAS is again, it's a dynamic analysis where you try to do dynamic scans upon it, try to find out different, all the OS top 10 vulnerabilities into it. IIST is again interactive application security testing. It's a mix of both. It's a SAST and DAS is the same, but it's just that it's a mix of both, and it's all about interactive applications, and then it gives you immediately all the results. These are some of the vendors that they do, and infrastructure as a code as well. Many of the times people say that okay, I looked upon to the application, I looked upon to different infrastructure architecture level, but what about something is if I'm managing via a Docker, if I'm launching my applications via Terraform, what about that? So these are the ones like you can use Claire, Anchor, DocScan that will give you good knowledge about vulnerabilities which are there at the launching of an infrastructure at the code level. So these are many times which get ignored, and then people don't want to go into it. But then these are really simple. You can use this code as well. I can give you example for Terraform as well. There's something called as TFSec. It's really good. It gives you vulnerabilities about AWS and Azure. It makes you understand, okay, if your Terraform code has a vulnerable service opening within AWS, for example, you're opening up an S3 bucket, which is making it public, it will immediately flag you then and there as well. So it's not even yet launched, but then at the just first level of check, it has given an alert. So this helps a lot, because now you have, if you go to the later step wherein the S3 bucket is already launched, the sensitive data is already exposed, you might want to stop that at a very initial level. That's why this will help you. And definitely as compliance as a code, it's a part of the code wherein there are different tools that you can use. RASP is again, that's what we call for an EDR solution. It's called as real-time application security protection. It's about your antiviruses and EDR solutions. So I would not talk about antivirus, because antivirus is now an old school, because they are dumb solutions. Dumb, I'm saying, because they just understand the signatures or MD5 sums of malwares, and they just map it to their database and try to flag it off. But then RASP or EDR solutions are really smart enough. They have AI and ML modules into them, which understands the attack vector. As in, even if you bring up with a new malware file, which has completely new hash, but then once it lands in your system, it is going to execute some processes. It's going to invoke certain steps. So that steps is learned by these systems, and then they understand, okay, there's something wrong. A system A is supposed to work in intended way 1. Suddenly it starts working in intended way 2. So that's where it flags it off, and then it's a really good logic. You guys can read it out on EDR system, why it's really important to have an EDR in your organization. Web application firewall as well. As you see, WAF is one of your first line of defense, and it helps you to safeguard from the basic steps or probably basic attacks that can happen. Talk about all Sql injection, XSS, and some basic level DDoS flooding and everything, API rate limiters and controls. You can have it all over your WAF. And then you have your monitoring tools as well, your chaos engineering. And the very last part is the vulnerability management. This is also very important, as you see that you need to keep on continuous scanning your infrastructure, your services and everything, and try to find out if those are vulnerable. And Archery is one of the best tools I've worked with, and it's an open source again. You can try that with that. And apart from this, just want to tell you that once you have all these things in place, you have your WAF, you have vulnerability management, your SAST and DAST, all the tools. You can inject all those logs into your SIEM platform or your logging platform, and then you can add on to some special algorithms on it. Yes, you can. This interesting topic called as data science in security. Try to look upon for it. Try to research around it. It's a really interesting part. It's really new that's happening in cybersecurity. So now you move from a protective mode to a predictive mode. Now you know that something is already going to happen wrong in an organization. You try to predict it way before. So that happens from your WAF itself. Your WAF logs it, try to understand, okay, somebody's trying to attack me. Is it possible that he might have leveraged something and he might be able to penetrate my system or my application? That's where this logs helps you a lot. And then you can put on this certain signals and smokes that comes in as part of the complete platform. And you can understand, okay, there's something wrong that's going to happen. And you can predict it way before. So yeah, these are the ones I wanted to talk to you, and now we'll move on to demo. Before we go on to demo, any questions, Akshay? Anything you want to talk about? You said that you did you get the information that you wanted?
This is really good to start. I already shared that with my DevOps team, and they said we're missing sec part is missing. So
yes.
it's really thanks for that, and we will talk, and I will get back to you if you need any help. Thanks a lot, Rohit.
Sure. Okay, yeah. Anything else, guys? Anything you want to ask? Until then, I'll start the demo. Are you guys able to see my screen?
Yes.
Okay. So I will start with the very basic thing is that what's a proxy? So this is something really manual. I'll tell you some of the automated parts that that can be done with this. This is a Burp proxy. A proxy is an interceptor. It's like I'm doing a man in the middle attack between the application and the server. So it's like me as a customer, and then I have my proxy set, and then I have my server. So what I do is that I'm able to now intercept all the requests and responses. Yeah, I'm able to intercept all my requests and responses in this, and able to manipulate as well. So I'll start with this. I'll give you an example which I've set up one lab for it. You guys can actually go ahead and try this. If you want to learn testing, you want to learn all the OS top 10, how to attack it, how to start like testing by yourself manually first, because it's really important that rather than jumping directly to automation, we should first understand how it's been done manually, what are the risks, and then how you actually exploit those risks. This will help you in a long run, because automation will only tell you what's wrong, but then if at all it's a false positive, you need to understand that why it's a false positive, and then you need to limit that false positive within your organization. Otherwise, it will be a really chaos for your developers team, because they'll come back saying that, okay, this functionality is not supposed to intend to work in this way, and why are you giving me issues which are false positive? You need to verify it by yourself. Now, when you do that verification, you need to understand these attacks. So hence, it's really I would say that just go through this OAS BWA, download it. It's a web application project, and what you can do is that you can just go to the first section, which is a web goat. I'll just give the password as user, and here you go. It's like you start your lessons, and you have all type of different attacks vectors. If you see here, you have your normal introduction, then you have your access control flaws, step by step. And then the good part about this application is that it gives you a check mark, as in unless and until you have exploited in a proper way, it will not give you a check mark. I'll just give you one example. Yeah, if you see this injection, the check marks, only when I've successfully exploited this, then only it gives you a green tick mark. And it has everything, guys. It's like it shows you give hints as well. If you want any hints, what exactly you want to do. It doesn't give you a solution at all, but then definitely hints and all, show cookies and lesson plans, and then everything what exactly is there in this lesson. So it's a good way to start, good to understand how the attack can happen. If you see, it has everything: IAC security, authentication flaws. Within that, it has different sections. You have buffer overflows, cross-site scripting, different types of cross-site scripting, and parameter tampering, and all different types of issues in there. If you want to see back here what's happening, this is probably the request and response which are getting generated. Now, as you can see that I can probably see everything. What's the JSession ID of this, like, and what's the response for this request. Now start playing around with this parameters and try to see that, okay, how can an attack, how can I can do scans on it. Just one of the best part of this is you can actually scan this. You have the target and you have the sitemap. Now, if you see it's a sitemap, now immediately I have visited all the different modules within the application, and now I have the complete repository in front of myself. So now I don't even need to do anything special for it. I just have to crawl each and everything, and within the proxy itself, everything will be properly captured. And then you can export this as well, as so that you just for your reference, if you want to know, your team wants to know what are different models, or within my application, I don't have the scope myself, I don't have the documentation at myself. It will help you a lot. It will help you to know what exactly where and which API is getting called. So what you can do is that you can actually do a scan as well. That's what most of people do. Even burp can be used as a part of the DevSecOps pipeline, where it does the spidering by itself, and then you just have to enable the scan. And once it gives you scan, then if you can see these issues, that it starts giving you some of the issues, like, okay, clear text submission of password. That means you can see that the password and the user and the password is going in a clear text format. I'll show you one here. Talk about XSS, reflected XSS, and if you see Tom, and I give password as Tom, it's allowed me logging. Now, for XSS to be connected, you have to see to it that which field you want to target. You want to target the field which has JavaScript running into it, and it gives you a parameter back, or some value-add information back. So this is where you just have to find out exactly what you're attacking. So as you can see that this is a search field, and there might be a script which is running at the background, and you can probably make it out from here. Okay, yeah, this is the search star. I know that there are some scripts, JavaScripts, which is running behind it. So let's see. Can I do an XSS attack on this? Yeah. So this is actually the payload. Whenever you just opening the script tag, you want to give an alert. Just say, let's say hack, and then you close the script tag. you see now this is the XSS pop-up that comes in now. The application is vulnerable to XSS. Now what happens is like you're saying that okay, fine, it's just about what I can do more about it. I'll show you. We just displayed a message which is a hack, and now what I want to do, I want to steal the cookie of this user. Now see, I get all the details within it. What are they? And I get the J session ID. Now this is J session ID is the cookie for the user. I can fix this. I can what I can do is that I can always like copy this. And wherever I see that if at all it's my own session, I send this to a repeater. I can fix this session by giving it the actual user session, and then I send this one. It's safe, and you can get the responses back. So there are different ways of attacks that you can do when you have such. This is called as session hijacking as well. If you know the session IDs, if you know the cookies, you can go on and attack the different users as well. So this is one of the examples. There's also one example for I want to show you guys is for injection. Okay, if you see that this is a logging page actually. I would like to intercept this. Now this request has been stopped. Now this, when I stop this, when I intercept this, it is still not sent to the server back. The password field is blank. Usually what happens is that if I say that it's blank, it's not going to allow me. It's not going to give me. Now what I do is that I don't know password of Larry. Again I'll do login, and I check that whether it's a Boolean logic which is running at the background, and check if it's vulnerable. So what I do in the password field, I give it a Boolean logic stating that 1 is equal to 1. So it's always true for it. That's it. I'm logged in as Larry now. I can see all his details around what's his salary, everything. So this is one of the examples for escalation. You can try this. There are different levels and different. Just for the time's sake, I'm not able to demonstrate everything, but it's really interesting. Do connect me back if you have any issues in this. You try to test it by yourself. Connect me anytime if you have any problem. If any of one of this tests you want to find a solution for it, I'll help you out guys in this as well. There's also one more interesting part I have kept for this demo session is the infra testing part. The very first is that you need to have Kali for sure, and it gives you vast range of tools and availability of like you can use a lot of tools within Kali if you want to do some pen testing work, and it's really important that you have. So I have a machine which is a vulnerable machine. It's not an application, it's just a machine. It's called as Metasploitable 2. I'll try to enumerate what are the services and ports which are open on that system. This is an Nmap scan. Nmap -f is the fast. That means I want to do a fast scan. SV is the version enumeration. I want to enumerate the versions on the ports and the services which are hosted on the server. Now, as you see, the port, the server which is open, it has these many ports open. We talk about port 21, 22, 23, 25, and I see that there are. I could even get the versions of it. That okay, wow, fine. I have VSF FTPPD, which is 2.3.4. What does happen with this? I copy this. Oh, there's a backdoor which is available for 2.3.4 version. This is where your reconnaissance happens. This is the every step that we are looking out for now. The steps that I told you before. That okay, this is the exploit. What I can see is that there's an MSF exploit which says use Unix FTP version, and I can get a shell back. Interesting. Let's do that. So once this is done, I would like to start MSF console. This is the Metasploit framework. It has list and knowledge about all the exploits which are publicly available. It has all those repositories into it, and then it's a really good tool if you want to exploit anything. It's really simple. I'll show you now as well. What I do is that I search VSFTPD. Well, I do have an exploit for it. And what I do is that I say use 0. It says no payload configure. That's fine. I say show options. You see, there's a field which is blank, which is our host. Okay, I say set our hosts. Because that's the IP address of my vulnerable machine. I say again show options just to verify everything is there, all good. I say run. That's it. It's already in. I found a shell. Now I'm inside the vulnerable machine. If I do an ID, I'm already root, pwd at the root level. Who am I? All the Linux commands which runs, and if you want to do ifconfig, I'm inside the machine. So this is what the steps which are involved in pen testing. You see, it's really simple. If you have those vulnerabilities present, if you have those services and ports open, you can go ahead and then exploit this in this way. And these are the different awesome tools like MSF console. Nmap is your initial reconnaissance. So if you see here this metasploitable 2, I'll give you details as well for that. It's vulnerable machine. Try that by yourself. Each and every service which are there are running which has vulnerabilities. You should try to test it yourself, learn about those vulnerabilities, how to exploit those vulnerabilities, how to get root. Sometimes this is where I directly got the root of that application of the server, sorry. But then there are some issues here which will not give you root directly, but give you $ first, and then you have to escalate your privilege to get root. So just try it out, guys. This is really interesting. You keep on doing these exercises. You can learn. You can start learning by yourself. Another part is the vulnerability management tool I told about, right? It's if you want to scan the server, you want to understand what vulnerabilities are lying. So let me check. Okay, I guess so. There's some issue with this open mass, but it's a really good tool wherein you actually can get reports around what exactly the vulnerabilities are lying. So all these machines which So there's all the ports which are get scanned by this automatic vulnerability scanner, and will give you all vulnerabilities you're lying. It's really used a lot in the DevSecOps pipeline as well. The OpenVAS, where if you talk about the archery tool, which I was talking about vulnerability management, it uses this as a vulnerability management tool, and it's a really good tool to have. And it's just that I don't know, it's creating some problem, but yeah. Try out, guys. So these are different attacking ways that we do, and try to use these machines and this test setups and learn about things, how you're supposed to hack. And then once you do this, then you can understand the automation part. That's what I'm saying. Is then you can actually get to know, okay, these are the ones actually are applicable to your application. So let me get back to, yeah. Okay, guys, can you see my presentation?
Yes.
Okay, so this is probably the concepts that we learned today. It's just a tip of an iceberg. There are a lot of things that you can do in security testing. If you see, it's really a big thing. It's like there are so many ways to do. There are so many different methods that you can apply. And today I just wanted to give you an introduction about just to give you an understanding of how the security testings are be done, how do we attack, how do we perform those tests and everything. So there's something remaining concepts is you can start by yourself. You start learning anything, any probably a chapter or within the security domain you like. You start researching about it and see that where it goes and takes you. And yeah, what's next? It's like read books. These are the books that really helped me a lot in my growing career in cybersecurity. Read these books. These are really good books, and it will help you to understand a lot of different attack vectors, because security is different. It's about knowing how things are supposed to be done. It's not really difficult, I'll tell you. It's just you need to know how you're supposed to attack or how you're supposed to exploit it. It's just that you need to know the way. Otherwise, you can. Otherwise, it's really easy. So yeah, definitely get a mentor for sure. You would definitely need a mentor in cybersecurity, and it'll help you a lot, because probably security is something about, it's about passion and ideas, different ideas and different vectors, and thinking around some complex workflows and try to find out loopholes and flaws into it. So yeah, and there are many online resources which are available. You can have a look into it. Practice those vulnerable web applications. I told you the OS web goat, and try to test those and try to see that whether are you liking it, are you able to test those applications, are you able to test your logic as well. It's really interesting. Do some at your weekends. It's fun to play with. And once you are done with those, like you're pretty confident enough, then start participating in CTF competitions. The CTF is the capture the flag. Those are big competitions. A team of hackers sit together, and they're like big prizes. I'll tell you, those are like big prizes they give away if you hack any system. So those keep on happening here on the calendar wise. You can start participating in those, build up your own team, and it's really interesting. So there might be a chance that you guys are doing your jobs 5 days a week, and then at weekends you're just hacking and you're still earning extra from hacking. So please do that. Try to do as much as possible. Try to participate in those competitions. Attend different conferences. Definitely, you have your black hat conferences. You have null cons. You have those online as well. Try to run those. Try to understand where security is moving in a new way. What are the new innovations that are happening in security? How the gamut of cybersecurity is changing as the technology is changing. Of course, like contribute to the open source as well, security projects. Definitely, there are a lot of people who wants to do more, and some people might have good ideas to do it. And please always contribute to the open source, because that will help each and every one of us. If you want to start your jobs in security, definitely start it from now. It doesn't like you don't need to have qualifications for it. If you start doing these basic steps, you understand the security flow, you make like you find out some bugs into the applications, you start participating yourself in CTF, you might even land yourself job in cybersecurity. Yeah, and then that's like take a life one step at a time. You can do this. Yeah, any questions? This is a really last thing. Any questions, guys? Anything you want to say?
Hello. Just a small question. I couldn't attend the first part of the session. So I can see that it is being recorded. Will the recording be shared with the whole group?
Yes, it will be shared, and even the presentation will be shared with you guys.
Oh, thank you so much. It was a really good one, Rohit. Cheers.
Thank you.
Thanks for doing it.
Thank you. Thanks a lot. You guys can reach me anytime, even if you feel you want to have any doubts, and if you already started the process of security, reach me out. I can help you out at any step.
Rohit, I see there are also some questions at the Q&A section.
Yeah.
We have access asking like if there are some online courses that you could suggest.
Yeah. Yeah, definitely. So online courses, I would rather say is that it depends on what exactly you want to do. Reach me out, ping me. Probably I can just give you my. These are my coordinates. Like you can reach me out on LinkedIn, and you can even also mail me. But I'll tell you which all courses that you want to do. If you want to start from the really basic, is that you do your CEH, as in which is a certified ethical hacker course. And the books which I've mentioned, start reading those. That'll be a good starting point for you guys just to understand how hacking works. But then if you want to do some specialized courses, like I'm already deep down into DevSecOps, but now I want to implement those in a proper way, but I do want to know learning, then I'll definitely suggest you guys. But then do reach me out, ping me what exactly you're looking out for, and then I'll share those courses with you.
That is great, thank you. Also, there are some questions about the books that you are suggesting. I guess it's the same, that if someone wants something, that they can always reach you out for more specific book recommendations.
Yes, for sure. Yeah, even for like as I told, like any special books that you're looking for only for forensic stuff, you want to just as even ask about the DLL file injections, and then if you want to know just about how I can triage a malware, there are different books for it. Do reach me out. I can always suggest you guys.
Looks like
Okay. Yeah, we are good. I guess that's a wrap. I hope you guys, everybody enjoyed. You got to know something like just an introduction, and then let's keep on conversating. Keep on reaching me out. I can deep down into a lot of other details. There are a lot of good things I've worked upon in my past career. I can share that with you guys. How to do a lot of different work in cloud as well. How to handle multi cloud platforms, and how do you aggregate that and secure your platform. So do reach me out, and look forward for my more sessions, because as I said, the DevSecOps is something really big, and then I would want to justify that topic properly, giving you out a proper session with all the examples, and then setting up the lab for you guys, so even you can interact with that lab. So for sure, like look forward to it. Look at our meetup handle, and keep you so you can keep yourself updated for more sessions. Yeah.
cool. Thank you very much. Thank you, Rohit. Thank you, Lily. Thanks for everyone.
I see that we have, I'm sorry,
Thank
we
you.
have one last question. Like, which language is good for ethical hacking?
Oh, okay. Which language is good for ethical hacking? It's really difficult. As an ethical hacker, you need to know not all, but then some languages. But then you can start with Python. There's a book called as Offensive Python Coding. Look into it. It's only about learning Python for offensiveness, or probably hacking stuff. You can start with that. But then if you're talking about you want to create some bots, and then you want to have like you can use Go language as well. Many of the nowadays security tools which are coming out using Rust as a language to develop some tools. So it completely depends what exactly you're looking out for. But then if you talk about only hacking, if you want to hack by yourself, then you can use Python as well. And just about for a QA people, there are a lot of Selenium scripts available that you can make as part of your testing, QA testing as well. And then you can use those scripts just to run and just find out the high level security issues which are currently lying in the code. So yeah.
Cool. I think then that's pretty much it. Thank you, Rohit, for the presentation. It was really nice. A lot of new information and really interesting topic. And thank you all for joining us today.
Thank you. Thanks, Eleni. Thanks, Sarge, and thanks everyone here. Have a good evening, and looking forward to meet you guys.
Sorry, Rohit, before you leave, someone mentioned they can't find you on LinkedIn.
Okay.
Apparently that URL returns a 404. So yeah, we will send you the proper link.
Okay.
Yeah. Along with the presentation and everything, we'll send you.
We'll send you the proper link. Yeah. Yeah.
Yes, thank you. Did we miss anything? No, thank you. All right. Thank you very much. Have a nice afternoon. Ciao.
Bye.
Thank you, guys.